more after 1 o'clock also, because we have started late. Okay, so protein. Protein structure. We'll discuss about that. Okay, so basically, when we talk about the protein, already I explained you what is protein. It is a polymer of amino acids, and amino acids are linked together by the help of which bond? Peptide bond, right? So when we discuss about the protein, first we will discuss about the primary structure. Okay, primary structure. Definitely when we talk about the protein, protein is having primary, secondary and tertiary structure. Okay, when we classify protein, protein will have the structure of protein. When we classify structure of protein, it is having classification of protein. We have primary, secondary, tertiary and quaternary structure. Okay, we have primary, secondary. Today we'll discuss some questions also. Okay, tertiary and quaternary structure. Primary structure, you can write here primary structure, secondary structure, tertiary structure and quaternary structure. Okay, so basically what is primary structure of protein? What is the meaning of primary structure? Okay, so in primary structure, first we'll discuss about the primary structure. Okay, so primary structure basically in that protein will bind with each other only by peptide bond. There is no any other bond will form in that. Okay, so in primary structure, sometimes they ask question which kind of bond involved in the primary structure? Only peptide bond, not other bond. Okay, so amino acids bind with peptide bond only, like this, methionine, okay, glutamic acid or isoleucine. So this is peptide bond. Peptide bond. Okay, so we can say that in primary structure, only peptide bond present. Only peptide bond present. Peptide bond. No other bond. Understood? This is easy only. Okay, so I'm going to erase this. Yeah. So, you know that what we talk about that many protein, like proteins are basically not functional in this form. Primary structure form, no, like we know that for functional protein, protein has to be fold. It has to be changed in different structure, like secondary, tertiary, quaternary. Okay, but basically in primary structure, no, protein only functions, but yeah, insulin is there. In that, in primary structure form only, it is functional. It is by folding it will make disulfide bond, but no, like yeah, what we already studied, but it is prominent. It is we'll say because for secondary, no, it is very important to present a hydrogen bond. So their disulfide bond is there, but we cannot say that is secondary structure, because in secondary structure hydrogen bond should be there. In primary, peptide bond, basically peptide bond. Sometimes like you can say that the methionine is there and the cysteine is there. In that case, they can form that disulfide bond. But insulin, always remember, insulin is the primary structure. Primary structure. In primary form, it is functional. Okay, but all protein won't be functional in the primary form. Protein has to be, we know that hemoglobin. Which form is there in hemoglobin? Huh? Yeah, globulin protein. Yeah. Which form? Quaternary form, no? Okay, so maybe protein will be functional in that form. Okay, so but insulin is there, the only peptide bond, and if folding will be there, so the sulfide bond can be formed between cysteine. Okay, so like that, yeah. So, so what about secondary structure? We'll discuss about the secondary structure. Secondary structure. Secondary structure. When we talk about the secondary structure, basically, in secondary structure, many classifications are there. Okay, actually, secondary structures of use actually. In that, many classifications are there. Helix. In that, helix, sheet, and coils. And coil. Okay, these structures are present. Understood? So when we talk about the primary structure, one thing, it is not always like straight only. Okay, it can be like this only. It can, these round structures, amino acid, and amino acid bind with the peptide bond with each other. It can be in that way also. It is not like it will be always straight. Okay, but peptide bond will be there. Okay, so we have to discuss about the helix, sheet, and coil. Okay, and quaternary structure, tertiary structure is also called, like tertiary structure is also called 3D structure. 3D structure. It is also called 3D. Separately, we'll discuss. And quaternary structure actually, it is the association of many monomers, like 2 alpha, 2 beta. Okay, like that. Quaternary structure. Quaternary structure, we can say it is association of many monomers like alpha beta, alpha 2 beta 2, like that. Okay, association of many primary structures. Okay, so now we'll discuss about the, okay, now we'll discuss, because why I want to discuss about this peptide bond, because we have to discuss about the rotation of peptide bond. Okay, on that basis of rotation, we will discuss secondary structure, and also we'll discuss about the Ramachandran plot. Okay, so for that, it is very important to discuss this peptide bond, the structure of peptide, or how peptide bond will form. Okay, so definitely, okay, this is the structure of amino acid, NH2, COOH, here R group, okay, R1 we can say that, and here H will be there. This is first amino acid. Second amino acid, same R2, H, NH2, and COOH. Okay, so what will happen? Bond formation between this amino group and this carboxylic group. Okay, or bond formation between this carboxylic group or this amino group. Understood? When bond will form between this amino group and this carboxylic group, amino group of first amino acid and carboxylic group of second amino acid, when bond will form between these, so that bond we consider peptide bond. Okay, so how it will be after bond formation? How it will be? This is basically, this is alpha carbon, this is alpha carbon, this is alpha carbon. Okay, and here this is alpha carbon. So what we'll do? NH2, H, R1, and here C double bond O, N. Okay, NH, and here H, R2, C double O, H. Okay, so this bond will say peptide, right? So what is the feature of peptide bond? Now you have to tell me, what is the feature of peptide? What you know about peptide bond? Okay, CN bond is basically peptide bond, the CN bond. Okay, so what is the nature of this bond? What is the nature? Huh? It means like it is having double bond character, it is having a single bond character. Huh? Hmm. Single bond. Okay. It is single bond. Partial pure single bond. Okay, we'll discuss about that. Okay. Peptide bond is like rotation around peptide bond is not easy. Okay, we cannot say it is like, yeah, pure single bond. Okay, because according to bond length, it is between single bond and double bond. Okay, when we'll measure bond length of peptide bond, it is between double bond, single bond. Okay, partial double bond also we can say that. Okay. So like basically structure of protein, no? Structure, shall I raise this? So how peptide, yeah, we say like this is the structure. This is the structure. And basically what happened? This peptide bond is resonance hybrid. It is resonance hybrid because of this double bond. It is resonance hybrid. This peptide bond is resonance hybrid. And you know that resonance structure, when any bond is resonance hybrid, that bond is rigid actually. It is difficult to break that bond. Okay, because in chemistry we have seen that benzene ring. If any compound directly attached with the benzene ring, it's very difficult to remove that compound. Okay, because that compound is resonance stabilized. Delocalization of pi bond, pi electron. Right? So peptide bond, you can write here peptide bond is a resonance hybrid. Okay, and basically when we talk about the peptide bond, it will absorb UV at 220 nanometer. Always remember, this is very important. Why this is important? I will tell you about this. Okay, it absorbs UV at 220 nanometer. 220 nanometer. Basically, when you will isolate, suppose that definitely you will go for higher study, research also you will do. Basically, when we isolate protein, any protein, okay, and when you will take the OD of that protein, actually, basically, we have isolated amniotic fluid protein, amniotic fluid peptide, basically, okay, amniotic fluid or follicular fluid peptide. In follicles, no, that oocyte will be there, granulosa cell will be there, and fluids will be there. So we have isolated that follicular fluid. Follicular fluid contains many peptides. Okay, many peptide or many proteins. So when we were taking the OD on the spectrophotometry, what we observed, like two peaks were coming. Two peaks, like this one. Okay, this graph we used to get. So we were very like one peak should be there, no? So then we can say that, yeah, this why two peak? Then we went through many research articles. So in that we studied, like, yeah, whenever you are getting two peak, that is only correct, because one peak for peptide bond and another peak for your protein, like your aromatic protein compound, aromatic like amino acid will absorb the light. One peak for that and one peak for peptide bond. So sometimes the experimental kind of question they can ask, like, okay, in protein isolation, how many peak you will get? Okay, we'll get two peak, one peak for peptide and another peak for aromatic. Okay, peptide bond, and another peak for we'll get for aromatic amino acid. Okay, they can ask this experimental question. Okay, shall I raise this? And one more thing, like CN bond. Already I told you, peptide bond, CN bond is having possess a partial double bond character. Okay, possess a partial double bond character. Why? Because of resonance hybridization. Okay, because of resonance hybridization. Understood? When we calculate the bond length, it will come between double bond and single bond. So that's why we will not keep it this peptide bond in single bond wala characters. It is not having, and double bond also, pure double bond also, because this is resonance structure. So any resonance, any compound which is resonance hybridized, that will have partial double bond characteristics, and that bond is very stable actually. Okay, any bond which is resonance hybridized bond, it is very stable bond. Okay, I think you already studied, like any structure which is directly any compound, directly if any compound is directly bound with the benzene, it is very difficult to remove that compound, because this benzene ring is resonance hybridized because of the delocalization of pi electron, because we know that in benzene 3 pair of pi electrons are there. Okay, so because of that delocalization, this structure, this bond, chlorine, is not having single, it is partial double bond characteristics. So because of that, it is very difficult to break this bond. Okay, understood, Mitra? Okay, so what are the characteristics of this resonance? The resonance causes the peptide bonds to be less reactive. Yeah, you have to write this also. The resonance causes the peptide bonds first to be less reactive compound to the ester. You write to be less reactive compound. To be less reactive. See, because of that resonance structure, it's difficult to break peptide bonds. Because of that, we can say that because of that, it is not that much reactive. Okay. And second, to be quite rigid and planar. Second, to be quite rigid and planar. Okay. Understood this? And one more characteristics to exhibit a large dipole moment in favored trans configuration. Trans configuration. How? Suppose that this is the peptide bond. Okay. If, because we can see that here hydrogen is here and oxygen is transform. Okay, so because negative ion is negative atom is opposite to the positive hydrogen. These two atoms in transform. Okay, so because of that, in that dipole moment will be there, large dipole moment will be there. Okay, positive is opposite side to the negative. So because of that, large dipole moments will be there in the trans configuration. Okay, dipole moment, you know, no? If any if any compound is there, in that atoms are there, if in that atom difference of electropositivity will be there. Suppose that one is electronegative and another is electropositive. So it will cause dipole moment. in that compound. Okay, so electronegativity or positivity difference will be there. So it causes dipole moment in that compound, right? What happened? Oh, from here. Wait. Let's try this check once. Switched off?
Yeah, it's switched off.
Okay. Yeah. Now we'll discuss about the rotation. Are you getting what I'm telling you? Huh? No. Yeah. Okay. So now we will discuss about the rotation around the peptide bond. The rotation around the peptide bond. Peptide bond. Okay, so this structure will be there, you know that C double O, this N carbon. Okay, this is N. Okay, terminal. Here carbon, this carbon will be alpha carbon. Okay, and this carbon will be alpha carbon, this carbon will be alpha carbon. This kind of a structure will be there. So what will happen when we talk about this? This bond. Okay, this bond can be rotated. This also can be rotated. Okay, this is peptide bond actually. This one is the peptide bond. This one is the peptide bond. Okay, this is peptide bond. It is planar structure, rigid, so it will not rotate. But yeah, like this bond between carboxylic carbon and alpha carbon, this bond can rotate, and between nitrogen and alpha carbon, that bond can rotate. So this bond will call it psi bond, PSI, and symbol is this. And this bond will call it phi, PHI, phi. Okay. Okay, so bond between this carbon, this, okay, is called omega bond. Omega bond. We'll discuss about this bond also. Omega bond. Okay. This oxygen and this bond. It is bond is called omega bond. So basically, we can say that rotation around the peptide bond is not permitted because of resonance stability. Sometimes they can ask which statement is true. Rotation around the peptide bond is not permitted because of resonance stabilization, or if in option that partial double bond character are there. Okay, that is also correct. So we can say that rotation around the peptide bond is not permitted. You write it. Okay, rotation around the peptide bond is not permitted. Okay. Next is rotation around bond connected to the alpha carbon is permitted. Yeah, bond connected to the alpha carbon. This alpha carbon, this alpha carbon. These bonds can rotate. Like psi bond and phi bond. It can rotate. Okay, these bond is having only Okay, these bond can rotate. Okay, understood this? You can write next point. Rotation around bonds connected to alpha carbon is permitted. Okay, so psi angle. What is phi angle? Not psi. What is phi angle? Phi angle. Okay, phi, it is angle around. You write angle around the alpha carbon and amide nitrogen bond. Amide nitrogen bond. Okay, alpha carbon, amide nitrogen. This alpha carbon, this amide nitrogen. Okay, so angle between this is called like psi. Sorry, phi. What about psi? What about psi? What will write in? Angle around the alpha carbon and carbonyl carbon bond. Okay, angle around the alpha carbon and carbonyl carbon bond. Okay, so you understood no what is phi angle and what is psi angle? Okay, phi means alpha carbon and okay, like bond will be there between alpha carbon and amide nitrogen. So that bond angle is called phi. Okay, and between alpha carbon and carboxyl carbon, okay, bond will be there, and that bond angle is called psi. Shall I erase this? Shall I erase this?
Huh?
Shall I erase this?
Ma'am, what is the difference between? Can you hear me?
Yeah, I can hear you.
What's the difference between carbonyl and carboxyl groups?
What? Carbon, it is carboxyl group only. Okay,
So
carbonyl and
is it the other name of that?
yeah, other name.
Okay.
Okay.
Yes.
See here what happened, no? Carboxyl, when we'll call it carboxyl, when it will be carboxyl, this form. Here OH already removed. Okay, now this is in this form. Okay, so now we can say this is carbonyl. Okay, because OH got removed from here. Right? So we'll call it carbonyl. What's there? Wait. Yeah. This C carboxylic group is this. Okay, so this is called carboxylic group, carboxylic bond. We will not say carboxylic bond, carboxylic group. This is okay. And what will happen? Shall I erase this? Then I will explain you. I'm erasing this.
Yes, sir.
Yeah. So see, I told you now this will be there OH. Okay, COH. This is carboxylic group. Amino group will be this. I will erase this. Okay, NH, then carbon will be there. So what will happen in peptide bond formation? This OH and this H will get removed, and water will get removed. One water molecule in one peptide bond formation. Okay, always remember, when one peptide bond will form, one water molecule will get removed. So this form is, we know that. This is carboxylic acid, carboxylic group. Okay, so here this group got removed. So now this. So carbonyl. Okay, so carbonyl bond, you can say that. Okay, this, you can say that carbonyl bond. Okay, bond between alpha carbon and this carbonyl carbon. Okay, so you can say that carbonyl bond. Okay, in that condition, you can say this bond is carbonyl bond. Carbonyl bond. Okay, carbonyl, sorry, this carbon is carbonyl carbon. Okay, because here we don't have carboxylic group. Carboxylic group already OH got removed from here. OH is not there. Okay, so we have only that C-double-O bond. Okay, so that's why we call it carboxylic or carbonyl carbon. Okay, because previously it was carboxylic group only. So one question arises here. Actually, I forgot to explain you. Sometimes what they ask, like suppose that 1, 2, 3, 4, 5, 6. 6 amino acids are there. So in that, how many bonds will be there? Peptide bonds?
5.
5, right. Yeah, exactly. Okay, 5 bonds. So how many water molecules will get removed when 5 peptide bonds will form? How many water molecules will get removed when 5 peptide bonds? 5. See, number of peptide bonds. This is very a favorite question for JAM VT. Number of peptide bond is equal to number of H2O removed. Okay. And suppose that we have 8 peptides. In that, how many peptide bond we can get? 7. Okay. So number of peptide bond, you can write peptide bond or number of peptide bond. In the straight chain, I am talking about a straight chain, not circular and all. Okay, in straight chain, number of peptide bond is equal to number of amino acid minus 1. Okay, if they'll give 14 peptide, amino acid, 14 amino acid, and they will ask how many peptide bond can form in straight chain. What will you say? 13. How many water will get removed? 13. Right. So these are the basic thing you should know about this. See. So, one thing I want to discuss, in a fully extended polypeptide, suppose that there is no coiling, fully extended polypeptide is there. Okay, polypeptide means chain of single protein. Okay, so in that, phi and psi both will be on 180. Okay, both will be on 180. Okay, they ask basically this question. If fully extended polypeptide is there, then what is the bond angle? Fully extended polypeptide is there. So what is the bond angle of phi and psi? Both will be 180. Phi also will be 180 and psi also will be 180. Okay, if fully extended, you can write here, if fully extended polypeptide is there. In fully, if not if, in fully extended polypeptide, this and this are 180. Okay. Yeah, and one more thing I want to discuss, like omega. What about omega 1? We already discussed, this is omega actually. For these two bonds, omega. Oh, no need to like go in depth. They used to ask superficial question from this. Basically, they'll ask Ramachandran plot. Definitely, psi and phi is very important. Rotation around pi and psi, they will ask this. Omega also sometimes they ask. Okay, so if transpeptide is there, transpeptide bond, omega is 180. Definitely, this is in opposite direction. This bond in opposite direction, no? So 180 degree. If cis peptide bond omega is 0 degree. How? Because if cis is there, means we can say no, this is 0 degree. Like that you have to remember. Okay, so when this will be in cis form, this peptide bond CN will be, length is 1.33 angstrom. Sorry, in transform. When cis form, it will be 1.32 angstrom. Okay, in cis form. Understood? Okay, this thing actually you should know. What is phi, what is I? Because what happened, no? Whatever we studied in our BSc, MSc, basically, like in our college, they will not teach much about phi and psi. Omega, they will not teach much. Basically, they will teach about your primary structure, secondary structure, tertiary structure. But this is why this is important, because this rotation and all what is somehow related to that secondary structure formation, the Ramachandran plot also. Okay, so that's why this is important. Okay, so shall I raise yes? Yeah. So second, we were discussing what is secondary structure actually. Protein primary structure we discussed. Primary structure means what? It is a straight chain of polypeptide. Okay. Secondary structure. Secondary structure, basically we already divided secondary structure in helix. Helix means how it will be. It will be like this, like this. Okay, sheet will be like this, and coil will be like this. Okay, this kind of structure. So, like always remember, peptide bond is only responsible for primary structure. Okay, always remember this. When we come to the secondary structure, here after peptide bond, hydrogen bond also will be there. Okay, hydrogen bond also will be there. So when hydrogen bond form in primary structure, then secondary structure forms. Okay, secondary structure forms. Means suppose that one primary structure is there, straight chain. In that chain, if hydrogen bond will form, so it convert into the secondary structure. And always remember, folding will be there. First, all protein will be in primary condition. Then folding will be there. It will change into the secondary structure. Again, next level of folding, it will change into the tertiary. Next level of folding, it will change into the quaternary. Okay, so this level of folding will be there. So if any folding will be there in primary structure, in that folding hydrogen bond form, so that primary structure convert into the secondary structure, right? So in secondary, what we'll say in secondary, which kind of bond will be there? Peptide bond. Peptide bond. You know, peptide bond is also called amide bond. Amide bond. Okay, and hydrogen bond. Okay, hydrogen bond. Both bond will present in the secondary structure. Shall I erase this? Let's do some classification. Secondary structure. Okay. In helix also, actually many helical structures are there. In helix also. Okay. When we talk about the helix. In helix, screw will be a screw. Okay, and amino acid basically L form and D form. Next is atoms. I will describe this one by one. Atoms will be 3.6, 13, 310, and this meaning I will tell you 4.4, 16. Okay, and hydrogen bond. On the basis of hydrogen bond, helix will be alpha type helix, beta type helix, gamma type helix, and pi type helix. Okay, so helix basically is divided into screw. On the basis of amino acid also, helix divided into levo and dextro. On the basis of atoms also, helix divided into three part. 3.6 meaning no. What is the meaning of 3.6? In that helical structure, 3.6 turns will be there. 3.6 helix will be there and 13 atoms will be there. Okay, 310 meaning of 3 and 10 means 3 turns, 3 helical structures, 3 turns are there and 10 atoms are there. 4.4 means 4.4 turns are there and 16 atoms are there. I will discuss this later, like with example I will discuss. Okay. And then next structure is sheet. In sheet, we know that parallel sheet and anti-parallel. Okay, and coil, we have turns, we have turn and we have loop. Understood? We have turn and we have loop. First, we'll discuss about the helix. Okay, in helix we'll discuss about all screw amino acid. On the basis of amino acid, helix divided to L and D. Atoms, on the basis of atoms also. In one helix, how many atoms are there? In that also it divides into three parts. Sometimes in one helix, like atom, like if 3.6 helix are there, atom will be 13. Okay, so in some helix, 3 helical structure will be there, 3 turn will be there, and a number of atom will be 10. So 3 kinds of things are there. Okay, and on the basis of hydrogen bond, helix divided into alpha, beta, gamma, and pi. Okay, sheet divided into 2 parts: antiparallel and parallel sheet, coil, turns, and loop. Okay, so first we'll discuss about the helix. Okay, we'll discuss about the helix. So what is helix? Helix is actually interchain hydrogen bonding. Okay, interchain hydrogen bonding. So not interchain, intrachain. What is the meaning of intrachain? Huh? Yeah, in single chain only hydrogen bond will form. So we can say that hydrogen bond occurs in main chain, and hydrogen bonding is parallel to axis. How it is? Suppose that this is the helical structure. So in this helical structure, what is the axis? Axis will be this, no? Huh? This will be axis. Hydrogen bond will be like this, between this helix and this. So hydrogen bond is parallel to axis. Okay, hydrogen bond will form in this way. In this way, it will form. Okay, like this. Hydrogen bond also form. So we can say that hydrogen bond is parallel to axis. Okay, suppose that this is the axis and this is the hydrogen bond. Understood? Shall I erase this? I will write one more thing. Helix former. Some amino acids are there which helps in the helix formation. Okay, which induce the helix formation. Helix former. That kind of amino acid is called helix former. So which kind of amino acid are helix former? Methionine, alanine, leucine, glutamic acid, and lysine. These are helix former amino acids. Means if these amino acids are present, helix will form. Okay, and what about helix deformer? Always remember this. It is very common. Helix deformer, no, it is very common. Always proline and glycine. Okay, it can proline, P for proline, G for glycine. You can write proline and glycine. Okay, so what is the function of this? It can break the helix. Okay, these two, proline and glycine, is actually helix deformer. If these two amino acids is present, what will happen? Helix will get break. Okay, it can break the helix. Sometimes they ask, which of the following combination of amino acid, if present, helical structure will form? Combination kind of thing they will ask. Okay, which of the following combination will present, then helix will form. Okay, so you have to remember the name. But so short form is no MALK. MALK. Methionine, alanine, leucine. Okay. E, glutamic acid. And lysine, K. Okay, so male K is the code for this. Shall I raise this? So helix. Helix. In that, the first division is screw. Screw. Screw, it is right-handed or left-handed. Okay, screw, in that right-handed helix, right-handed or left-handed. In right-handed, what is the structure? Right, yeah, tell me.
In between, your voice keeps breaking. Sometimes.
The voice is not proper.
Even now it's breaking.
Now, okay. Now, am I audible? Yeah, am I audible? Yeah, Suraksha, am I audible? Yeah. Okay, okay, yeah. So right-handed helix, okay, it's two only. Right-handed and left-handed. Right-handed means clockwise. Okay, left-handed means anti-clockwise, like this. Okay, this kind of helix will be there. Okay, on the basis of screw, right-handed and left-handed. Okay, on the basis of amino acid, okay, helix on the basis of amino acid, AA. We have two types, dextro, levo amino acid and dextro amino acid. Okay, so we know that when we talk about the amino acid, levo is the common, L form, not levo. L form is the most common. You can write most common amino acid, L form. D form is not present everywhere. Okay, it is present in the peptidoglycan. You know that in bacterial cell. Okay, cellular peptidoglycan is there. So in that, some D form amino acid present. Okay, sometimes they ask. I think you know now that in peptidoglycan in bacterial cell wall. Okay, D form amino acid. It is very rare. Okay, so like we can say that nature has selected L form of amino acid and D form of carbohydrate. You know that D form of carbohydrate is very common, not L form. D form of carbohydrate and L form of amino acid. So nature has selected these two. Okay, so that's why these two are very common. L form is, you know now, amino group will be left side. D form is amino acid will be on right side. Understood this? Shall I raise this? So we already discussed that, yeah, in amino, in a secondary structure, hydrogen bond will be predominant. Okay, hydrogen bond. So we'll see that hydrogen bond between N and nth amino acid. Nth can be N2, N3, N4, N5. Okay, so suppose that hydrogen bond between N and nth amino acid. So suppose this is the structure. This is the structure of amino acid. N is there, alpha carbon. This N will be there, peptide wala. This is also alpha carbon. This N is there, This is also alpha carbon. From here to here, and this is called N. From this N to this, it is called N plus 1. Okay. From this to this is called N plus 2. From this to this is called N plus 3.
Write something in that.
Yeah,
Cells.
yes, you can take. Okay. You're getting no? This? Huh? This hand, no, correct. This to this, this to this. Yeah. So, like, so yeah, we so hydrogen bond. What's this like hydrogen bond? Wait, I'll write it black color. Hydrogen bond form between N and N plus 2. So how we'll write it? Suppose that this is the N wala hydrogen. Sorry, N wala this carbonyl oxygen, and this is hydrogen. Okay, this hydrogen is N plus 2 wala hydrogen, na? This hydrogen. So what will happen? Here also it can form hydrogen bond, because we know that hydrogen bond can form here because this hydrogen attached with the electronegative group. Nitrogen is electronegative group. Okay, so that's a partial positive charge is there here. Okay, this is negative. So this hydrogen bond can form between N and N plus 2. Understood this? It can form between N and N plus 3 also. Like this. Like this also it can form. So we'll say N and N plus 3 in this condition. In this condition, we'll say N and N plus 2. Okay. So N and N plus 1, basically it will not form. Okay, it is difficult to form between N and N plus 1. Always it will form N and plus 2, 3, 4, 5. Okay. If this bond will also form, no, this N and N plus 1, so there is no much folding will be there. These are very close. Okay, these are very close. One is here, one is here. If bond will form also, there is no much folding. But if bond will form here and here, that will create folding. Okay, that is the reason of folding. That is the reason of helical formation. That is the reason of sheet formation. Understood? One table is there. You have to remember this table is very, very much important for you people. Okay, I will write that. Shall I erase this? I'll write that table. Huh? That table is important for you. question also I'll discuss related to this table. 1 or 2 questions will be there related to this table only. Okay, here N plus, it can be 1 to what I have written, helix name and amino acid and atom. Write this N plus what? Helix name, amino acid and atom. When bond formation between N and N plus 2, it is called gamma helix. And in that 2.2 helix turns will be there, and 2.2 turns 7 atoms. 7. Okay, 7 atoms will. Okay, yeah. Understood this? It is actually not turns actually. It is number of amino acids and atoms. So 2.2 number of amino acid will be there. And in 2.2 number of amino acid, 7 atoms will be there, like carbon, hydrogen, nitrogen, oxygen. Okay. So this question is they ask basically in IIT JAM. And when bond formation between N and N plus 3, that helix is called beta helix. Okay, in that 3 amino acids will be in one helix and 10 atoms. Okay, this is most common actually. What I am writing now, this is most common. This is, you can say that, most common. Most common. In that, what will happen? N plus 4. Hydrogen bond between N number of amino acids. I'm sorry, this is N plus 4, not N plus 2, N plus 4. Okay, so this type of helix is called alpha helix. In that 3.6 amino acid, okay, and 13 atoms. Okay, suppose that one number, 2 number, 3, 4, 5th wala amino acid is there, first wala amino. So bond formation between these two. This is N plus 1, N plus 2, N plus 3, and this is N plus 4. Okay, so hydrogen bond between first number of amino acid and 5th number of amino acid is the most common helical structure, which is called alpha helix, and in that 3.6 amino acids are present in one helical turn and 13 atoms are there. Okay, when N plus 5 will be there, bond between N and N plus 5 means number 1 wala amino acid and number 6 wala amino acid. Gamma helix will form, and in that 4.4 amino acid will be there and 16 atoms will be there in one helix. Okay, so what is the meaning when we call it N and N plus 5 means 1, 2, 1 plus 6 means first number and 6 number wala amino acid. Okay, so you have to understand in this way. Understood this? Yeah, tell me, Saksha.
What is the amino acid?
What is
Meaning of 2.2 amino acid? It's
2?
2.2.
Yeah, 2.2 means suppose that Have you studied the DNA structure, helical structure, double helix? In
Yeah.
that also, this kind of thing will be there. Means one amino acid like this, hydrogen will be there, alpha carbon will be there. Here, alpha carbon will be there. So, suppose this is the one amino acid, we consider this one amino acid. So, in this one amino acid, 0.6 part of that amino acid will present. Suppose this is the helix, this is the helix. Okay, so two complete amino acid will be there. Two complete amino acid will be there. And for third amino acid, only 0.6 part of amino acid will be present in one helix. Okay. That is the meaning. In that, you know that in DNA also we have to study this. Okay, 2.6, 3.6 like that. Means 3 complete amino acid. 3.6 is there. 3 complete, suppose 3 complete nucleotide. And 3.6 means in one nucleotide, 0.6 part. Okay, in 1.6 part will be there. Understood this? So, like, yeah. So, you have to. Shall I raise this? Now we'll discuss about the beta sheet. Now we'll discuss about the beta sheet. Okay. Sheet structure is there, no? We'll discuss about the beta sheet. Okay. Sheet or beta sheet. This is the secondary structure only. So this will be, suppose that this is the helical structure. We already discussed. This is the helical structure. And if this helix completely extended, so it can convert like this, no? Suppose this is a spring and we will stretch that spring. It become like this, no? So this is actually called sheet structure. Okay, this is helix. It will extend the helix. It converts into the sheet. Okay, so now we'll discuss for the sheet former amino acid. Sheet former amino acid. Which kind of amino acid will help in the sheet formation? Wife only, WYF. What is the meaning of wife? Tryptophan, tyrosine, and phenylalanine. Okay, these three amino acids are sheet former amino acid and sheet deformer, sheet breaker. Same, you know, breaker is only proline and glycine. Okay, breaker will be these two only. Because we already discussed, glycine is the most flexible amino acid. That much flexibility also is not required for helix and sheet actually. Because we already discussed, glycine is the simplest amino acid. Simplest amino acid means it is not having any chiral carbon. Okay, 2 hydrogen atoms will be there. Okay, 1 carboxylic group and 1 amino group. So this amino acid is the simplest amino acid, more flexible amino acid. Okay, so for sheet and helix, that much flexibility also not required. Okay, and proline is most rigid amino acid. Because of that aromatic chain, one chain is there, not aromatic, but cyclic chain is there. Because of that, proline is the most rigid amino acid. So because of more flexible and more rigid, these two amino acids are deformer or breaker, either sheet or helix. Okay. Understood? Yeah. So in beta helix, basically, in beta sheet actually. In alpha helix we already discussed the hydrogen bond will be intra chain, means in single chain only hydrogen bond will form. But in beta sheet, hydrogen bond is interchain. Okay, hydrogen bond is interchain. Interchain. It is not intrachain. And perpendicular to the axis. There it was parallel to the axis. Here it is perpendicular to the axis. How? Suppose this is a one chain, this is another chain. Okay, and hydrogen bond will form here like this between opposite chain. Okay, and this is the axis of this beta sheet, and this is the axis, and here we can see that hydrogen bond is perpendicular to the axis, means angle between hydrogen bond and axis is 90 degree. Okay, angle between hydrogen bond and this axis is 90 degree, perpendicular to each other. Understood this? Now we'll discuss what is structure of beta sheet, parallel and anti-parallel. Okay, parallel and anti-parallel. Parallel beta sheet structure. Parallel beta sheet. So we'll consider like this. Carbon, this carbon, this carbon, make this structure to understand easily. Okay, so it is important. Yeah. So how hydrogen bond will form? Between this, between these two. It will form in very irregular manner actually. Not in a regular manner. Suppose this is hydrogen, it will form like this. Okay. Like that. This is hydrogen. Okay. So here it will form with this bond, this hydrogen. Okay, this oxygen. It will form in irregular manner actually, like not exact, incorrect manner. Okay, so anti-parallel. Hydrogen bond will be in not in regular pattern, right? This is C terminal and this is N terminal. N terminal. So this is C terminal and this is N terminal. So hydrogen bond between two peptide chain, which is in C terminal like this, CN, CN. Okay, but anti-parallel will form like this. Okay, the structure will be like this. This is parallel beta sheet, and this is anti-parallel. Anti-parallel also we'll discuss, right? Like this it will form. So in parallel beta sheet, we can say that inclined hydrogen bond. Hydrogen bond is not straight, inclined. Okay, it is not straight. Inclined means little bit inclination will be there. Huh? So that's why it is less stable, and it is also less common. Okay, so hydrogen bond will be inclined in parallel beta sheet. Okay, and because of that it is less stable and less common also. What, Netra? Understood, no? Shall I raise this?